Hello, I'm George Mayhem, the Managing Editor of IoT Now. Welcome to today's webinar. Today's topic is achieving global IoT connectivity right now, and I think that's the really important thing, is to be able to move the market on quickly. I'm delighted to be joined by today's panelists, Saverio Romeo, the Principal Analyst at Beecham Research, and also Neil Hamilton, the Vice President of Business Development at ThingStream, which is a recently launched division of Myriad Group, which I'm sure we're going to hear a lot more about during today's webinar. Just before I hand over to Saverio to give his part of the presentation, I would point out this is an interactive session, so do feel free to put questions to the panel by typing them in the Q&A box, and I'll put them to our panelists at the end of the presentations. I'm very interested in this topic, so let's forge ahead and hand over to Saverio, who is going to set the scene for us. Saverio, over to you.
Good afternoon, good morning, or good evening, depends on which part of the world you are. So my name is Saverio Romeo. I'm the Principal Analyst at Beecham Research, and I'm going to introduce what Neil will discuss in much more detail, which is the topic of connectivity. That it has come back quite strongly in the last 1 year and a half for two main reasons. One, from one side, the LP1 story, so the low data connectivity, let's say like that. On the other side, the 5G story, the high data connectivity. So it's a topic back on at the top of the agenda in the IoT community, and I'm trying to just picture the key things here. In this slide, in the first slide, you see our Beecham sector map, in which this was an M2M kind of style map, if you want to make a critique to that, in which we show the whole application of the M2M. And those applications at the time required different forms of connectivity. Yes, was a lot of cellular there, but there was also some satellite, there was also some fixed. Now, into the IoT world, what is happening? Is happening that this application-centric approach of the M2M starts to become an interconnection of applications, because we are dealing with spaces in which we gather different type of data, we use different type of devices, we use different protocols, and we want to use, most probably, different forms of connectivity. So there is not just one connectivity for all, but probably there is an integration of different forms of connectivity in the same smart spaces. And I think smart city is an example on how you can find the fiber optics, the cellular, the LP1, and so on. So if we just stay on the long-range type of connectivity, the landscape of connectivity in front of you are extremely rich. So you have on one side the cellular world that goes from the 2G to the coming 5G, and then you have the strong role of LP1, the role of fixed fiber optics is becoming also quite relevant. Satellite also, and these things can be combined together for the need, the requirements of IoT solutions. The short range is also another area of extreme richness in terms of connectivity aspects. But I think here we want to discuss a bit more the long range side. And in terms of how the market landscape will look like, on this slide you can see a snapshot of our 2016 breakdown per technology of long-range connectivity, and you see in 2020 the presence, a strong presence of LP1 around 25%. I want to spend a little bit more before passing the role to and the audience to Neil on the LP1, just to briefly explain here what is the landscape in front of you. You have the two big families, the unlicensed families and the licensed families. On the unlicensed families, you have low-end Sigfox that I cannot see well the logo there on the slide, but you have many others. And on the license side, you have the one that are coming from the cellular world. And you know that in the cellular world, we have 3 standards at the moment that are coming into the market, into the marketplace, NB-IoT, LTE-M, and EC2G. Now, why this is important, why I want to spend a bit more on this, because I think the LP1, the real potential of the LP1 is to enable a set of applications that were too expensive to deploy in the past if we were using a 2G connections. So one of the key aim is to enable all a new set of applications in all the different markets that we have in our sector map that maybe were not deployed. And I think there are good examples around of these in agriculture and smart farming. For example, precision livestock is taking quite a lot around inspiration from LP1 on monitoring irrigation systems and so on. Because LP1 provides cheaper solutions, long battery life, a good range, so all elements put together that can enable a whole set of new applications. So saying that, I want to say that it's not just applications that are moving, let's say, from a 2G, the use of 2G towards LP1, but there will be also new applications going directly to use the various forms of LP1. And these charts in which is in these slides is our, again, graphical representation of potential applications in different sectors. So it's our basically Beecham research map, and we added a new layer with different applications. So LP1 is very important for the coming years for certain parts of the IoT, the low data IoT, but there are the 5G will have its importance on the other side of the data bandwidth, data utilization spectrum. But there is many other type of connectivities. And the emphasis I want to give you, and I want to leave this my brief contribution, is that we are going towards scenarios in which different forms of connectivity will be put together based on the requirements of the specific IoT solutions. So we will have very different IoT solutions with very different connectivity forms. And with that, I leave the audience to Neil and to discover with him Myriad Group and ThinkStream. Thank you.
Thank you, Saverio. And again, good morning, good afternoon, good evening, everybody. So I'm Neil Hamilton, the VP of Business Development at Myriad Group. And we have a division called ThinkStream, which is it's related to this topic I'm going to lead you through now, which is it's kind of a reflection on the market today, and hence why we're talking about global applications and global connectivity. Because there's a lot of appeal, certainly in all the kind of the hype we hear about the low power technologies that are coming to market, both the licensed and unlicensed. The appeal of low power and ultimately low cost is obviously one of the driving factors here. But when you look at global businesses or applications that are served on a global level, they really want to benefit from these, low cost and low form factor, long battery power, features as well. And we think the market, there needs to be some clarification in the market about how people can achieve that. And more importantly, how can you do that today? So we'll take you through that subject. And I think also, if we look at the way the markets are changing, so today we'll take a look at 3 kind of near or real use cases or real vertical areas where we are engaged with, applications where people are trying to enable IoT, low bandwidth IoT, across the world. But interestingly, certainly from our experience, we're talking to more and more manufacturers of things who want to sell them on a kind of SaaS basis or anything as a service, which means they need to be connected wherever they get sent in the world. And they really don't want to have the challenges of, shipping products to local partners or warehouses then deciding which are the best kind of SIMs or networks to use depending on what they're going to do. And really, that needs to have a real streamlined approach if you really want to achieve a goal of just shipping products from Germany, UK, wherever you manufacture them. And when they arrive, they just connect and they work and they enable either new efficiencies or new revenue streams for what you're trying to achieve. So we've looked at this from a slightly different view. Rather than looking at new standards and all the new emerging technologies, we're actually looking at what's in the market today. And our pedigree is working with GSM core networks, and that's led us to kind of bring a proposition to market, which is gaining a great deal of interest, and we'll kind of cover it off here, but with the details of this. So one specific area where it's commonplace, asset tracking. Although the term IoT is buzzing around the market and has been for a few years, I think asset tracking, from what I can tell, it's been around for many years, and typically that's been served either by satellite. Or typically today it's kind of an RFID stroke cellular data proposition that will underpin the connectivity for the tracking of assets. But again, if you think about the actual use case, many of these assets are just sending small bytes of data on an infrequent basis. They don't need high bandwidth. They don't need gigabytes or megabytes of data on the kind of plans that underpin the underlying commercial contracts. They literally just need to wake up, and wherever they are, they just want to ping status, and that should be then consumed into an IoT platform, which should obviously make the application part relatively easy to operate. But again, the core things we're looking for, or companies are looking for, they're looking for that reliability, the ubiquity, to know that wherever I send my thing, be it a piece of fine art that I'm tracking when I send it from a auction house to a buyer in wherever it may be, South Africa, whatever, I want the confidence I can track that all the way. So what do you use? And one of the common connectivity options is going to be GSM, because it is ubiquitous. It is the most ubiquitous connectivity option on the market today, and probably for foreseeable future. The ability to have long battery life, however, in some of these containers and things where we talk to end customers, they don't have the option of having these things powered. So if you haven't got a powered object and you need to track the asset for a long period of time, you then do start to look at the low power wide area network technologies, because their promise of 3, 5, 7, even 10 years battery life is really appealing, because then that your things can last for a long time in the field and they don't just go dark on you. And typically when people are exploring cellular data solutions, you need a fair old bit of power to kind of maintain the battery life for a modem to seek, find and connect to a data network, send its payload, and then power down, or remain in kind of a tick over mode to continually send status. That will drain power. But again, wouldn't it be great if we could do that or lower the power consumption using today's GSM networks? And ultimately the low cost of these devices as well. So you obviously want trackers. Some organizations we're talking to want disposable devices. So again, thanks to the GSM world and the maturity of it, certainly 2G, 3G and LTE, there's commonly available in large volumes components, because it's not new technology, and therefore you can start to build cheaper tracking devices, so that they are less important if they do go missing, or at the end of a journey, they don't need to be returned back to base. They can just be disposed of. That's all now doable because of the cost driving down all the underlying electronic components behind overall GSM. Then if we take a look at some of the emerging segments and sectors, we've got remote monitoring, and there's more and more organizations looking to drive efficiencies in, say, agriculture. It's a kind of the graphic here suggests. Environmental monitoring. All of these things can be vastly improved if they're connected up into IoT platforms, and then preemptive action can be taken. All of that has got huge benefits, and there's no end of use cases for all the different verticals that we saw on Saverio's slides. In every segment, there's almost a remote monitoring case study. But again, if you're sending something either from the manufacturing, so if I'm a manufacturer of soil sensors, typically I'd like to get those live as fast as possible if I want to provide the end-to-end service, which many of these types of companies are looking to achieve now. So again, you want to be able to ship from wherever enable these things to just be connected and working in the field, guarantee that they're connected, and you may want to update their firmware and things like this. You definitely need a two-way communication. But again, the usual appeal of what the low power offering presents, so the fact that they can be battery powered for a long period of time in the field, is also very appealing. So again, if we wanted to use a global network such as the GSM network, we'd need to make sure that some of these features can be included in order to roll something out today that's useful. And the final kind of area of the three areas I was suggesting to look at today is around predictive maintenance, which again, there's no end of use cases as we visit shows and read the media. Predictive maintenance is huge in terms of energy saving and preemptive, monitoring of vehicles and all sorts of things. And so there's clear cost efficiencies and new revenues to be generated in this market, and there's lots of new kind of startup technologies and divisions within existing companies where driving data into IoT platforms to make better decisions about when to service machines or fill up fuel or whatever it might be. The use cases are obvious, but again, you need reliable connectivity. So if I again am sending equipment even domestically to anyone in the UK, I'd want to make sure that I can confidently connect the data back to the IoT platform to guarantee the service works end to end with the least friction as possible, in trying to remove as many of the kind of components needed in that value stack to deliver this. So all three of those use cases and some of the other global considerations, they all need certain key ingredients. We spoke about ubiquity, so we know we need the confidence that our things can work anywhere. We want them to be low power, so if they are battery powered, we know they can last for long periods in the field. And very importantly, when it comes to the certainly predictive maintenance, we want to ensure that our devices are connected securely. And that's got a whole, there's probably webinars just about this subject happening all the time as well. Because security is key. If I'm going to connect up, an elevator system or a hospital's air conditioning system to a predictive system, you need to make sure that there's security in place that's not going to affect the actual systems themselves, because they obviously impact on people's lives or things like this. And then intelligence, and we'll come on to this ingredient, but again, modern connectivity is more than just moving the data. It's about moving the right data at the right time. And that's really an important thing as we go forwards, and I'll cover those in a little bit more detail as we go forwards on this presentation. So as you kind of have worked out, we're very much advocates of GSM technology, and there's a little known component within all GSM networks, which is a type of messaging protocol called USSD, and this is commonly found across all networks, but it doesn't use the data layer within the network or SMS. And because it's a core part of the network, it's easier to leverage that as something for a ubiquitous connectivity option. And so as a business, we actually do provide SIMs and connectivity to this component within the network. And because it's not using data, you need less energy to effectively connect to base stations to beam your data back to your IoT platforms. But it's fascinating, because when you start looking at, well, which technology should I choose for my application, if it's anything but, if it's moving beyond your country or boundary, or you've got moving objects or anything that needs tracking, then GSM is the best option. And then by removing the data component, you start to drive down the energy usage. And so we've got more details on specifically this, but again, it suddenly creates almost a global network, which is low power, which is fascinating when we start, and as we have engaged now with a number of organizations, again, it's not a particularly well-known technology, but when you see it being embraced and being used, it's incredibly effective. And as I mentioned, there's the security aspect. And if you are using effectively this particular messaging protocol, is not using TCP/IP. There's no IP involved, and therefore, when you've got an endpoint such as a device that's being monitored at an airport, for example, and it's sending its telemetry data or its conditional data back over the USSD network back to gateways that then forward onto your IoT platform. The leg between the device and the gateway has no exposure to the internet, which actually solves a real issue, certainly in the industrial sector, where organizations are very concerned about bridging the air gap, connecting operational systems, which are actually doing real jobs for real life, to the cloud. So it solves some of those problems around security in a very simplistic fashion. The fact it just simply doesn't use TCP/IP removes the need for having to worry about finding all necessary security standards and things to go into the actual device and back at your server side. So it's quite fascinating. And then we touched on intelligence, and this is an area where we're going to see whatever application you're building, there is a need for sending less data quite often, rather than just put in a cellular SIM, a database SIM, and just send all data continually back to your IoT platform for further analytics. Effectively, you're filling cloud storage up with more and more data, and the question really is, do we need to send all of that data all of the time? And if you can create some intelligence in your solution to only send data when there's conditions met that change, such as temperatures drop, so someone needs to know about the norm has now changed, then you're going to send a lot less data. And if you're sending less data, again, you're sending less information, you're effectively using less power, and the whole solution begins to benefit from the fact that you've used a connectivity type that is intelligent. It's not just a pure data pipe that you then have to layer on more and more intelligence, usually at the servers, with more and more resource and people and costs. So we're going to see more and more of this as we move forwards. And I highlight on this slide, a protocol called MQTT. This is becoming a very popular protocol for which devices or things can talk back to the IoT platforms. And this, effectively, in the ThingStream proposition, is baked in. Effectively, your devices would communicate this language from the get-go, and you can layer on and change and adapt your intelligence within the core network as you go. But again, from a global perspective, from anywhere on the planet, from any type of device, effectively, providing it can latch onto a GSM network. So what we found is, what we're seeing, and maybe you're experiencing this as well, is in all those target segments that Beecham have broken down, there's many projects occurring where people are evaluating different types of connectivity, and that's on top of having to think about what type of device they need for their solution, what server components, what applications. There's many things and many components you need for a solution in IoT. So our goal from ThingStream's perspective is to remove as much of that as possible. And as I say, if we can bake some intelligence into a very secure network that's ubiquitous today, that's easy to connect to, we remove a bunch of those problems. We can speed up projects and get them live sooner than later, rather than waiting for maybe a particular type of new technology to go live in our domestic country or globally or in our target market where we sell our products to. So we think it's a very fascinating area to start talking about using GSM, but using this rather different methodology, which is very exciting when you start looking at how the problems it can solve for all these different types of use cases today. So to kind of summarize from my perspective, USSD is a little known technology. We speak to many analysts and many people haven't heard of this. But interestingly, it's ubiquitous today, and ThingStream have packaged it in such a way that it's IoT ready today from a global perspective, which is now solving real problems today, which is fantastic.
Great, thank you very much, Neil. That's fascinating and particularly interesting. We've now got a poll question, which I'd be grateful if the audience will answer, so we can discuss the result. The question is, do people consider two-way communication within an IoT solution to be important? And your choices are yes or no. I'll read the question again. Do people consider two-way communication within an IoT solution to be important? And the choices are yes or no. Right, let's see what the audience think. Oh, that's a fairly ringing endorsement of the importance of two-way communication with almost everybody saying that it is considered to be important. Neil, was that the sort of statistic you were expecting to see?
Yeah, it's better than, it's a higher number than I expected, which is really good to see. And I think we've certainly seen just over this year alone more and more organisations initially thinking they need to collect data from their things to improve their businesses. But I think once they start thinking about the end-to-end solution, and if you're deploying a product abroad or wherever it may be, you may not want to go back to it. Then you will want to kind of either change its condition. So if something is, if conditions change and there's a problem, you might want to change. You might want to wake your device up more regularly because you want to keep monitoring that situation. And for that, you need this two-way communication. But it's interesting to see, because we've also experienced a number of organisations that do not see that as important. So for us, that's a really interesting number.
Mm-hmm. Saverio, what's your view on that? I'm kind of with Neil here. I expected probably maybe 2/3 of the audience to say that, having seen the amount of one-way communication projects that I've seen that have been deployed. Does this surprise you, Saverio?
Yeah, there's 93.1% is phenomenal. Is higher than I would have expected, but at the same time represents kind of an evolution towards some form of maturity of the use of IoT M2M connectivity. Also reflects the fact that you do not just control, but you want to receive data back, and you want to take some decision too, which at the end of the day is what we want to do with the IoT. So yeah, maybe a bit too high. Maybe I don't know. I would expect something like that in 2019. As a good analyst, I need to forecast, but definitely in line anyway with the expectation. Also, with the debate is happening on the connectivity, and two-way communication is an important feature that is kind of required for all a number of applications in the IoT.
Okay, thank you. I'll just open the floor to questions now. We've had some questions in already, but there's still time to ask the panel questions. So the first question I'd like to ask, I'll ask Neil this: how much data can I transmit over USSD/ThingStream? Because I guess the
sure, okay. Yeah, absolutely. Yeah, so if you think, certainly with the ThingStream solution itself, it's effectively communicating MQTT, protocol over the USSD network. Each USSD message is formed of 182 characters, and I'm told that equates to around 160 bytes per message. And you can pretty much send one per second. So you can sort of start to map out if you're a telematics provider and you need 50K every 10 minutes or something, you can start to understand how that compares against other technologies.
Sure. So, I mean, I think that's a very interesting point. And another question that's come in asks the next most obvious question, which is, what's the cost of this solution? And I guess that is a relevant thing. How much data can I transmit, and what's it going to cost me? Is, I guess, the equation that comes into play most often in supporting deployments. What would you view as the kind of cost profile? I mean, I don't think we need to get into dollars, but I think we need to sort of put the context around what the cost of USSD is likely to be, perhaps in contrast to some of the alternatives.
Yeah, no, absolutely. For actual, for USSD itself, I think it depends on which mobile carrier you speak to, or however it might work locally for you. What we do at ThingStream, what we're doing is, because we're sending these IoT messages effectively, which is the format of the MQTT format over the USSD network. So there's no heavy lifting to do each end for someone to develop those protocols to work on the device or back at the server. We see that being an overall value add for the service. And typically our service is $1 per device per month. That's typically how that works. So yeah, That's the thing stream approach.
Okay. We've had another question come in, which is how, and it's going to be difficult to answer because it says, how do the mobile operators view the question of USSD versus NB-IoT, CAT-M and others? And obviously none of us are mobile operators, so we can't share that view, but I think we can probably comment on whether they see it as a threat or an opportunity, and whether the capability will continue to exist as GSM networks evolve. So maybe if we can talk around those issues and operator attitudes, I think that would be interesting to explore.
Yeah, for sure. From my part, we see USSD. It's a small data transport option. It's not a.
Yeah.
It shouldn't be seen as something competitive to data for sure. Those applications, they are. It's for a different use case. It's for sensor networks and things like this. And so in that terms, you're effectively competing with the unlicensed low power wide area network options that are in the market today. So that's our view. We certainly don't see it as being something that's negative to an operator's business. And as we see their new standards coming through, the NB-IoTs and things like that, I think, as Saverio said earlier, each of these kind of protocols or technologies will find their niche. NB-IoT, from my understanding, is excellent for smart cities and high bandwidth penetrating buildings and all that kind of stuff. It's not necessarily the thing you'd use for telematics across a country or across borders. So I think
Sure.
I think there's a place for all of these different approaches to live.
I've got another question that's come through about the devices, and basically the person asking the question wants to know if there's a specific device type that supports this connectivity, and by that I think it's pretty clear that they mean USSD. I think that's it's important to understand the devices, the device kind of marketplace, because that's one of the limitations is always trying to get the devices that are compatible with the connectivity. So is there a specific type of device that deployers need to have in order to use USSD connectivity?
Sure. The great news there, as I said earlier, the economics of building devices which are GSM enabled, where you could be buying GSM modules from Simcom, Quectel, Telit, Sierra Wireless, all these providers, their costs are going down all of the time. All of these GSM devices support the appropriate 3GPP standards for USSD. So it's really down to, you just need to enable the device. Typically for our service, you're acquiring a SIM and then a small SDK that you embed on the device to use those commands on those modules. But that's the beauty of this particular solution. It's using stuff that exists today. It's not necessarily. It's not looking to use a prototype new module from someone. It needs testing and things like this. So the costs, the ubiquity of those GSM modules and their prices in each market is the cost of the underpinning cost of the actual device.
Sure. Okay. This leads quite nicely into another question that's come in. It says USSD for IoT-based messaging sounds new, but what is the traditional use of USSD? And do you see any issues with bandwidth because of the IoT signals that will be traveling over USSD?
Yeah, that's a good question. Well, there's more than enough bandwidth because the USSD is kind of within the core SS7 network. It's not using that data layer. And from what we can, from what we've seen, there doesn't appear to be any issues there. The bandwidth is always available to hold a cell network together, and that's typically because it's a core messaging protocol that's used within the actual network for various different reasons. The most popular consumer use that I've certainly ever come across and our teams are involved with in another division with our business is very much around customer service features for mobile operators. So typically, and this is the most popular format, is typically you get these star hash menus on your device, and so I think on say some networks you can type in, if you're prepay users, you can type star hash 6D hash, and you get your prepaid balance presented to you immediately. That's all using that USSD messaging layer. And so it's been around for a while. We have a sister division within the business that run all sorts of services over USSD in Latin America and across Africa and elsewhere, which are all using these services for consumer use. But yeah, generally in the UK, Europe, US, we don't experience them as much, but they're all there native in the network.
Great, thank you. I guess another important question, aside from the cost and throughput, is the power consumption of the device and how long a USSD-enabled device could typically last. Do you have any information you can share about the lifespan in terms of from a power consumption point of view of a ThingStream-enabled device?
Yeah, we always find talking about battery power quite tricky, because quite rightly people are set out in building an application that they want maybe a sensor to last in a remote location for 3 years before they have to go and deal with it or swap it or whatever, maybe even longer. And so what we find is we typically get involved in saying, well, how often do you want this to do you want it to wake up from scratch as the for the actual device and call the network and report its condition and then turn off completely? In which case, whatever size battery you put on that, it will help define the length of time you want that to last. It's a difficult question to answer. What we have seen though, from working with actual customers who have been testing prototype devices that are using either cellular data and then they kind of disable that and then they just use USSD just to get some idea of power consumption. We have seen reports of 120% increase in energy efficiency, but it's difficult to just work with that because it depends on how hungry is your device and how hungry is your application. If you have a device that's always on, then you're going to drain the battery much quicker than a device that's waking up every 10 hours. But because it's technically not doing as much work and the modem's not working as hard, you're therefore using inherently a lot less power.
Yes, I guess like for like, it would be a different situation. I mean, battery life's obviously always affected by temperature and all sorts of things, so it's a difficult question that is kind of a little bit like how long is a piece of string. But I guess all we can say is to sort of put it in a like for like scenario and talk about, as you said, that lessens communication load. So that's quite good. I've had a quite interesting question in that says, I've heard that GSM is being turned off and soon there will only be 5G. So is this only a short-term solution? What are your views on that? I'd like to bring Saverio in as well on that because I think that's a kind of industry-wide issue to address.
Yes, sure. Neil, do you want to go first? Shall I? 2G has been sunsetted, as we say in the IoT community in the US, but I think European operators are a bit more, if you want, cautious about that. So there is no sign of an official sunset, for what I know. There is definitely the idea that the 2G can be somehow substituted by various forms of LP1, but there is also another school of thought that believe that everything can coexist together. In addition to that, we need to take into consideration that European operators have quite a large 2G footprint or customer base, if you want. So I think in Europe it's a bit more difficult to see a decisions like happened in the US. 5G is coming, but I think 5G is coming for other reasons, for other type of applications that we are not discussing here, for enabling all a different world from this one, for enabling the connected cars, driverless vehicles, the use of artificial intelligence, the use of VR, and so on. so has other forms of justification. In the 5G working group, there are also discussions about, let's say, the extension of the cellular LP1 in the future of 5G. But I think 5G has its own motivations. I think that there will be, let's say, a battle between the 2G and the LP1 in getting the connections. It's a bit too early to say how this battle will end up, because we need to see how also the NB IoT LTE-M solutions here in Europe will take shape, how their growth will be, their adoption will be, the business model will be. I think there are quite a number of questions that require observation of facts before being answered, I think. So for the moment, 2G will be here. And then 2G, as Neil said, is used extensively in many other parts of the world. It's not the case that EC2G has been designed as a low-power wide area network cellular aspect using 2G for the reason that the use of 2G is not dead, actually, the other way around. So there will be, at the moment, there is a coexistence there, and there is, even when 5G will come in 2020, let's say the first kind of commercial networks, no, to my knowledge, no one is really saying to kill 2G completely. So, yeah.
I think that's probably quite a long way away, and it's probably not a natural thing for the cellular industry to do. I think they'd rather use as much of the asset they've invested heavily in deploying as possible. So I think that gives us a fairly long horizon in terms of 2G being available in Europe. I mean, obviously it's different in the States. But that actually brings us on to a good question about the idea about these different approaches becoming harmonized, because one of the questions we've had is, are there any standards governing LPWAN, NB-IoT, and these kind of alternatives for interworking and interoperability? Because it obviously occurs to me that all these choices that are coming to market will be adopted, probably quite sensibly by organizations that choose the most appropriate for their need. But it does seem to me that having this larger state of devices needs some means for there to be some degree of harmony for interworking and interoperability. What are your views on that?
I think there is, let's say, the variety of the LP1 world and its richness in all the forms we know are getting together somehow in order to respond to the question of integration, interoperability. And to the question that rather to live in silos, maybe we could find a way of talking to each other. And I think there is a very interesting working group in ETSI, which is the European Telecommunication Standard Institute, which puts together people from different LP1 schools. So the Sigfox, the ultra narrow band, and the LoRa. I don't know if that working group, that discussion will lead somewhere, but is an interesting sign that the problem you raise is felt and by the industry, and some discussion is required. Then there is another approach, which from other organizations in the industry, that they claim that the market will decide the winner. I don't know. I do not embrace that school, because I believe the IoT is very context-centric. Each solution has its own requirements, very specific requirements, very different from one application to the other, and probably the connectivity needs to satisfy those requirements. And therefore, maybe we should have, why not, a plurality of connectivity forms. Then it's a question of business model, service of the money, revenues, and so on. But ideally, this is what the IoT is. Is diversity, is multidisciplinarity, is in this case, is multi-type of connectivity.
Sure, thank you, Saverio. Neil, do you have any views on this kind of idea of enabling better interworking as more and more technologies start to coexist in the marketplace?
I think, as Saverio said, I think usually the market starts to dictate how this stuff, how that happens. If you think of a practical point of view, if I just think of my technologies that I'm using, when I walk into my home, my cellular phone automatically flicks onto the Wi-Fi network. There's intelligence built in to enable that to happen for efficiencies and all that kind of stuff. So that's a clear example of my network operator working out how to enable this to work. So I think we're going to see things like that appearing, within the devices over time. So as soon as something moves out of a domestic market, if it's vehicle tracking, it's just a good example. If I'm getting a low insurance premium because my car has always known where it is and how I'm driving it, and it's all good stuff. Whether I'm driving it or not is a question, depending on the future of cars. But they need to know where it is. But if I decide to take the car from the UK, where I'm based, and take it into France, suddenly I might leave my domestic market where I might be using, it might be connected up to LTE or something like this, or NB-IoT, whatever. But then I go into a country where there's not so much, the coverage isn't so good. Then that's the automotive manufacturer would have to think about how they solve that problem, and that would lead back to the technologies behind it. So it would go back to the module manufacturers, and people would have to solve those problems with real world use cases. And I think we'll solve it. We seem to be continually good at solving these problems.
Yeah, I think that's the classic challenge, really. I mean, it's an interesting thought that we're getting into a segmentation situation. One of the questions that's come in has been about observations that NB-IoT will receive nationwide support in China, and does that imply a possible scenario of market segmentation at the boundary of the continent as well as at the boundary of regional purchase power? And I mean, I think it's probably pretty clear that when a nation commits to rolling out a technology, it's backing a certain horse for certain applications. But I think, as we've talked about a lot today, there won't be only one answer to this question. So, as you've just said, when a car drives across a border, it needs a means to switch to the best available source of connectivity that it is compatible with. So, I mean, I guess that really is the challenge, to be able to kind of be almost like multi-band in the olden days when Europeans went to America and had a multi-band handset, so they could use CDMA on a GSM phone. So, do you see that sort of need maybe to feature devices?
Oh, I think that's we'd see the similar revolution of that. That those problems are solved through, at the component level. And so, I think my view is we'd probably see all of that just happen again. Now we're just unifying maybe 5 or 6 different, radio technologies into a single layer, if you like, of recognition somehow.
Yes.
I think why. I mean, the reason why China is supporting NB-IoT in this way is the Chinese government I think is quite evident to the audience who is following this space. But at the same time, I do not see as an issue. Is actually this richness of connectivity needs to be present in each country. So I'm thinking about Belgium, which is an interesting example. In Belgium, basically, there is everything. There is a Sigfox network, there is a LoRa network, and there is an NB-IoT network. Per constitution issues in Belgium, these networks, when they declare to be nationwide, they need really to be nationwide, in a sense that even the Antarctica, where Belgium has some territories, there needs to be the network. So to that extent. The issue is, the question is more, how do we harmonize all that? What type of business model how we imagining on these networks? What type of diversification in terms of applications? I think the questions are, in my opinion, are more on the business model. How do we do revenue? How do we generate revenue out of this network? If at the end of the day, the philosophy of deploying this network is to make them, or one of element of this philosophy is to make the approach cheaper for the end users. So the question is more at this stage, in my opinion, becomes more business model oriented type of questions. And I welcome the plurality of networks in a country, because this network, as I said before, can enable different applications properly, meeting the requirements of the applications. It is a challenge, as Neil said, but at the same time, is also an opportunity. The challenge is that we need to create harmony in all this. And not always this LP1 world has moved in harmony. I think it starts to move in harmony, and the different players start to talk together. I think the HETC working group is a very harmonic example of this change of approach. Yeah.
Yes, I mean, I think we've moved on from the idea that there will be one winner, because it's clear that this is such a diverse and fragmented marketplace, and the requirements are so different, and it's clear that different types of connectivity are ideal for specific types of applications and less than ideal for other types, as Neil was pointing out earlier. You know, this is a marketplace of very distant extremes, where there are very different business models as well to underpin the cost of whichever type of connectivity is used. And in some applications, there's a business case to spend a lot of money on things like satellite connectivity, and in other areas you want the cheapest, smallest bearer that can be found for the lowest at the lowest price point, as long as it has resilience and a level of security, which we probably shouldn't get into the security question today, because we're nearly out of time. I think maybe we should just have a kind of closing question, which I'd like to put to both of you. And I think the closing question I have is, what role do you see USSD having in the next 5 years? I mean, do you see it being a mainstream enabling connectivity for IoT? And what sort of timescale are we looking at? So I'll put that to either of you first.
Sure. From our perspective, where of course we see, you know, a resurgence, if you like, in the interest of this particular type of technology. You know, the way we're specifically sort of wrapping it up, so it's IoT ready, I think, and then, you know, it's no doubt going to appeal, certainly in these global scenarios where, as I said before, products are being shipped abroad, they need to connect, and all these new models that are appearing, and also to alleviate some of the existing models in the world where, you know, at the moment there's things, you know, RFID is very popular, but it's a good substitute to kind of streamline those business areas. I think it will coexist, and I think with providers like ThingStream, you know, coming to market, and you know, and we're creating a huge amount of interest. We've got some fascinating projects and things underway. I think that will naturally, you know, create more interest and maybe some competitors to come to the fore as well. So I think, I think it's a, as I said earlier, a little known technology that is perfect for small data transport.
Sure, great, thank you, Neil. Saverio, what's your?
I mean, I believe in the coexistence of different options of connectivity, and the three set of applications that Neil highlights into his presentations are three very vast group of applications. There are three concepts there that reflect on several applications on different sectors and subsectors. So I think for the next 4 or 5 years, I see the coexistence of these solutions. Then I think each solution has the market responsibility of revenue generating, and that will somehow maybe define the success and the existence maybe of some of them in the period that goes behind 2020 towards 2025, towards 2027. So for the moment, I strongly believe in coexistence of these options. And
okay, thank you, Saverio.
Yeah.
I think we're nearly at the end of the time that we have, so I'd like to take this opportunity to thank the panelists, Neil Hamilton, the Vice President of Business Development at ThingStream, which is a division of Myriad Group, and also Saverio Romeo, the Principal Analyst at Beecham Research. Also, thanks to you, the audience, because without you, we don't get to have these events and have the stimulating questions that you put forward to us. So many thanks for joining today. I hope you found the webinar useful, and I look forward to you joining another IoT Now webinar in the future. Thanks very much, and goodbye.